All right, this is page 5, and we're going to draw energy bar graphs and energy flow diagram, or just the energy bar graph. So we start off with all elastic energy here, and it's going to get converted into kinetic energy. So the energy stored in the spring, it says find the energy dissipated if the object slowed to a speed of 8 meters per second. So let's be clear. We launched at the speed of 10, and then we slowed to a speed of 8. So the interesting part here is let's get the original elastic energy. So the original elastic energy would have been E elastic equals E kinetic, which is fine. So we end up getting here E elastic equals the 1/2 mv original squared, and that's going to be 1/2 times 5 times 10 squared, which ends up being 250 joules worth of energy. So that's, yeah. Now we want to know the energy dissipated if its speed slowed to 8 meters per second. So now we're going to have E elastic equals this E kinetic plus E dissipated. So we start off with a 250 joules of energy, and this gets converted into some kinetic, 1/2 mv, but it's 8 squared plus E dissipated. And so we're going to end up getting 250 equals 32 times 5 is 160 plus E dissipated. And it turns out I'm losing 90 joules of energy when I finish this. So that is page 5. And I think we're going to continue on page 6 as well. So a pendulum has a length of 2 meters. And we want to know its period. So T is 2 pi square root of L over G, which is 2 pi times the square root of 2 over 10. So when we actually finish this up, we're going to end up getting, got to be careful how we plug this into our calculator. So it's going to be 2 times pi times, so that's going to be about 6 or so. Hang on. So let's just take this. So 2 divided by 10 is 0.2. Let's take the square root of that, and then we'll times that by 2, and then by pi. So we're getting a period of about 2.81 seconds. Now we want to know how long would such a pendulum need to be on the moon to have the same period. So now we're going to have 2.81 seconds equals 2 pi times the square root of L over 1.6. So let's be careful. I'm going to rewrite this as 2.81 over 2 pi, okay, equals the square root of L over 0.6. And I'm going to simplify a little further. I'm going to put this 2 pi in parentheses as well, because I just want to make sure you guys get the right, y'all get the right calculation on your calculator. So it's going to be 2.81 divided by, so let's try that again. So 2.81 divided by, I'm going to divide it by pi. And that gives me 0.8944. And then I'm going to divide it by 2 again. That gives me 0.45, or 0. I'm going to not round, 0.4472 equals the square root of L over 0.6. And I'm going to go ahead and square both sides. And then I times by 0.6. And I'm getting a length equal to 0.12 So on the moon, a 12 centimeter pendulum has the same period as a 2-meter pendulum on Earth. So now here's the idea. Here's the pendulum, and we're gonna take it all the way up here so that it's got a height of 0.2. And then we swing it through this circle. So we're going to have MGH, but that's G on the moon. So, and again, I needed to give you a mass for this. I did it again. So 21 and 23, and we'll skip. But I'm going to give you a bit of practice with this. Use M equals 0. Let's use M as 1 kilogram and actually do this. So we're going to have 1 times 1.6 times a height of 0.2. And when we do that, we're going to actually get 0.32 joules. And then we want to know its kinetic energy at the bottom of the swing. That's going to be 0.32 joules of kinetic energy because of conservation of energy. And then the speed is going to end up being mgh equals 1/2 mv squared. So g is 1.6, height is 0.2 equals v squared over 2. So we're going to actually end up getting that 0.64 is v squared. V ends up being 0.8 meters per second. And the explanation for 23 is you don't need to calculate the kinetic energy by doing 1/2 mv squared again. Conservation of energy. Guarantees that Eg equals Ek. We'd actually done 24 and 25 and 26 in a previous example. Let me just do 26 just to be safe. So if the period is 4 seconds and the wavelength is 2, V is lambda f. So f is going to end up being 1 over 4 because that's 1 over t. So V ends up being 2 over 4, which is 0.5 meters per second. So that's pages 5 and 6 of your practice exam.